Hello, and welcome to another week of online learning. So far, in our discussion of relations, we've learned about plotting ordered pairs on the Cartesian grid and how to calculate the slope of a line segment. Today, we're going to continue with slope, and we're going to be looking at how the slope of parallel lines are related. So on the grid, we have two line segments, line segment AB and line segment CD. And I want to calculate the slope of each line segment. So there are two ways to calculate slope. One is to use the formula rise over run. Rise refers to up and down, and run means forward and backwards. So you're dealing with your horizontal. So if I draw in a right triangle that connects A to B, using the idea of rise over run, to go from A to B, I counted down 2 squares. So that means my rise is -2 because I had to go down. Then I count over the squares forward till I get to vertex B, or to the ordered pair B. And I count 10 squares. And I went forward, so my run is positive. So my slope is -2 over 10, which reduces to -1 over 5. Now that's using the formula rise over run. While if you are working with ordered pairs, there's another way to do it, which is also related to this formula rise over run. The rise is essentially the difference in the y values, and the run is the difference in the x values. So if I go back to my grid, the coordinates of A are -4 and +5. So I'm going to write that in. So I've got -4 on the x-axis, and I had to go over 5 on the positive y-axis. The coordinates of B are 5. Okay. I went over 1, 2, 3, 4, 5. Oh, sorry, it's 6. It's 6, comma, and I had to go up 1, 2, 3. So it's 6, 3. So now if I use the coordinates and the slope formula, I'm going to write this underneath. The slope of AB, we use the letter M to represent slope, would be the difference in the y values. It doesn't matter which one you use first as long as you are consistent. So I'm going to take 5 from the A point, subtract 3 from the B. Those are my y values. My x value is -4, so it's -4, subtract +3. Oh, sorry, it's 6. I got my numbers mixed up. So now I'm running out of space, so I'm going to move over to the side. 5 take away 3 is 2. -4 subtract 6 is -10. The only difference here is that my negative sign is in the denominator, and that's okay, because when we reduce this, it still reduces to 1 over 5. The negative sign can go in the numerator, it can go in the denominator, or it can go in front of the fraction. The important thing is that the overall slope is negative, which makes sense because our line is going downward, so it has to have a negative slope. And now we're going to repeat the process for line segment CD. So if we draw in the right angle triangle to go from C to D, I had to count down 2 squares, down 2, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares, because I went forward 10. And when I reduce this, it reduces to -1 over 5. We can repeat the process using the ordered pairs. So the coordinates of point C are -7 and -2. And the coordinates of D are 3 on the x-axis and down 4, so 3, negative 4. So if I want to use the formula for slope using ordered pairs, the slope of CD is equal to, I'm going to start here, negative 4 is my y value, and underneath I'm going to put its partner x, right underneath, because this is important. The order here has to match up. The first two numbers have to come from the same ordered pair. So negative 4 subtract negative 2, and 3 subtract negative 7. Now negative 4 subtract negative 2 becomes negative 4 plus 2, which becomes negative 2. And in the denominator, so it's positive 3 subtract negative 7 becomes 3 plus 7, which gives us 10. And this simplifies to give us negative 1 over 5 as well. So whether we use the rise over run formula or we use the formula for ordered pairs, in each case we find that the slope of line segment AB and line segment CD is equal to negative 1 over 5. The slopes are the same. When two lines have the same slope, they are parallel. The lines will go in the same direction and they will never intersect. Conversely, if two lines are parallel, then we know they must have the same slope. And we conclude with some examples. If line segment CD has a slope of 1/3 and line segment has a slope of EF, and line segment EF has a slope of 1/3, the two lines must be parallel because they have the same slope. And if we're told that two lines are parallel, this is the symbol for parallel, then we know they must have the same slope. So if I tell you that line segment CD has a slope of negative 2 over 5 and AB is parallel to CD, then it too must also have a slope of negative 2 over 5.